now we are maybe moving towards reusing as well. Well, more specifically, we will talk first about reprocessing of medical devices. So we invited Andrea to come speak with us about reprocessing in Germany. And maybe just to say that we are aware that reprocessing is not currently allowed in all countries in Europe. It is allowed in some countries, and even where it is not allowed, maybe this can still be changed. So I think it's still interesting to hear about it because it is something that is done in many countries in the world. It is done a lot in the US, in the UK, in Germany. So maybe we could also do something to increase its uptake in other European countries. So yes, you can join on stage. Here's the clicker and the microphone. Thank you.
Okay, thank you. Hello. Yes, you already heard my name. I'm a cardiologist from Germany, and I was astonished to be invited to have a talk here because sustainability in hospitals is not a very great issue in Germany, although everybody thought Germany is a country which cares about sustainability. But we have in medicine, although I think there is a single area, it's about Berlin, where it is maybe a little more consciousness. But me, I'm from Bavaria, and I will, not originally, but I live in, and that is in the south of Germany. And but I'm lucky to have the possibility to be a part of this conference. So I start. My topic in my daily work is electricity in the heart. I'm an electrophysiologist. That is a small part of cardiology. Not a small, it's an important part, but you know why electricity, maybe it was an Italian who had the first experience about it because he was a researcher in batteries, and his wife, so is the legend, had some fork legs on the table for preparing for the meal, for the dinner. And it was Luigi Galvani who saw that the fork legs moved when they had contact. So he found out that muscle cells work with electricity. And it was a Dutchman who did the main work on it later on with these instruments, and he gave us the development of the electrocardiography, because the heart is a muscle, and everyone who works in medicine have seen this electrocardiograph once, and this is derived from the skin, and you see all the cells from the heart in one graph, how they work. And what is my topic now is the topic of cardiac electrophysiology is to look inside the heart, what is in every cell. It is a branch of cardiology, and our science is focusing on the electrical activity, and electrophysiology is usually used in a clinical context to describe studies who are invasive. So we go inside the heart and with catheters recording the spontaneous activity and the cardiac responses to electricity. Mostly we use a procurement electrical stimulation, like a pacemaker we have inside the heart. And the basic is that there is semi-permeable membrane in every cell and over the cardiac cell, and we have a shift in ions who make the whole heart as a dipole and every cell, And when we study this, we use catheters inside the heart. We normally go from the groin. No, it doesn't work as this. Oh, from the groin, and put our catheters inside the heart. First the right atrium, the left atrium, and here the ventricles. And what do we use? For this, we need material. We need these catheters. They are like long cables, and they have at their tips, they have electrodes who are placed to the region which are of interest. That is the conduction system of the heart. So this is the AV node, this sinus node, if you are a little specialized in medicine. And we do not only do this examination, but we can also we stimulate about these tips and these electrodes, and we can also do ablation with some electrodes. They have platinum or gold inside at the tips, and we can do with radio frequency very small lesions to ablate some structures who are doubled or who are not needed for the patient, or who are scarce and who do harm the patient because they have ventricular or atrial tachycardias. There are those tips who have platinum or gold inside, and they're for wide radio frequency ablation, and also there's the possibility to take other energies like the coolness, cryoablation. This is, but not, they are in use, but they are not eligible not yet for reprocessing. But these catheters, they are the catheters. The catheters are very expensive to buy, but there's a growing industry in this because the EP studies and ablation techniques developed more and more in the last 20 years. And the industry delivers us more and more different catheters. Some of them are also irrigated, the catheters. The issue is to cool the tip. When you use radio frequency energy here, you heat the tissue. And if you have to want deeper lesions, not on the surface, but deeper in the myocardium, you have to irrigate it with a saline solution, and so you have a lumen in your catheters. Yeah, that's also not that good for reprocessing. I show you later. Also, we have some catheters who are not so simple with the tip and the electrodes on. So there are some like basket catheters or like a grid like this. They are flexible, and there are some have a lot of like arms or a special surface. And when you look in a catheter lab, in an EP lab, electrophysiology lab, first you see a lot of technology, because we do not use only the catheter. You have the consoles and the technology to see the signals you take inside the heart. You had a lot of screens and different systems who have to work together and to connect together, are connecting together. We build up the picture of the heart because we map the whole heart inside, or the chamber of interest, maybe the left atrium of the heart, and so it is overwhelming technology. So this, as you can imagine, this is not a room where you think about a lot of environmental, because you are issues, because you are working with all this technology and the industry, and you don't think about how can I save anything here. I have to handle the technique, and I think this is one of the topics, though, that cardiologists are not so interested in the whole society, in reprocessing or in environmental issues. So what we do, or we create an electroanatomical mapping of the heart with all these catheters, and then we got they are all color coded now, all the signals, and we have not only the ECG from the surface, but now we have also the signals inside the heart, and we can do we can imagine where is my signal, where is my electrical activation in the heart, and at which point of the action potential of the heart. And then with my catheters I have a lot. I do not only have one catheter in the heart. That is not enough. As you know, maybe from the angiography, the typical topic of a cardiologist who does in the cath lab angiography maybe in a myocardium infarction. So we need some more catheters, at least 2. But in the average, we have 3 to 4 catheters for one procedure for one patient, because of the really the complex activity of the heart. So you have to have catheters in different locations inside the heart. Here some examples. We have catheters who are very softened and who are not steerable. You put them inside, and they maybe to the AV node, the His bundle, and then they stay there, or in the right ventricle, they stay there for the whole procedure. But you have also catheters like endoscopes who have to be steerable. And the industry who delivers us some catheters, they show us or they give us the information already if we can reuse catheters. So some companies do like this. They give us an information similar. So they are not only single-use devices, but there are other companies in this field who do not give us this information. They don't want to reuse the catheters, because there are many. They want to sell more for us, as I asked some colleagues if they are conscious about this economic issue, they said no. I never thought about if the company give us the possibility to reuse, yes, and so we can't develop our own catheters or deliver our own catheters, but we can look about what the companies give us, but that is in cardiology, in this special field, not so easy. When you have one system, I thought I showed you this colorful mapping system. When you have one mapping system from one company, you are obliged to buy the catheters from this company. This is crucial. I can't, because these systems are very complex and they don't work maybe with other catheters from other companies. Yeah. So this is maybe also an explanation why cardiologists are not such aware about different possibilities. Yeah. So once you buy a system, you are obliged to stay with this company. Okay. How often do we use EP procedures? I thought it is a small part of cardiology. It is not so often used as we do angiographies with people who have coronary heart disease, but we will use it more and more because not the congenital electrophysiology heart, the arrhythmias are the problem, but the acquired, I think it's an acquired arrhythmia, that is atrial fibrillation, will increase incredibly in the next years. And the best therapy for atrial fibrillation is the ablation. We have no other really good therapeutic options except of prevention of atrial fibrillation. And we have a lifetime risk for atrial fibrillation, 1 in 3 individuals in Europe when you reach the age of 55. Yeah, so you will see that is an increasing problem, and we will use more and more of these catheters for ablation in the future. These are our German dates, and we see here in the last 10 years the increasing rate, and that will go much more up in the next years. And I learned already obesity, hypertension is also due to microplastic in blood or in our environmental, the chemical products. And this is the main issues who increase the rate of atrial fibrillation. Our experience in this field is in Klinikum Nuremberg. We are in Nuremberg, in Bavaria. It's one of the largest municipal hospitals in Europe. And we are now also part of a private university, I would do but not yet so much EP studies, only about 500 to 600. But this will increase in the next years. We think that we are in 2 years ago we will double our procedure because we are a growing team for these procedures. And what did we use in the special field of reprocessing in this year? 1/3 of these catheters and of these products we sent, these catheters, we sent to reprocessing. 1/3 was catheters and 2/3 were cables, because every catheter has at the end there is a plug for a cable. You have to connect the catheter with your system. And fortunately, in Germany, we have the possibility to reprocess and to send the catheters and the cables to a company who did it for us. We use it about 20 years already. But reprocessing failed in 22%. But a good part was redelivered to us, and we can use it again. How often can we use and how often can we reprocess these catheters? That depends on the catheter, from 2 to 10 times or maybe 20 times. Cables are much often more reprocessed until 50 times. What have we to do with the catheters? We have to send them back to this company, or not back, we have to send it to the company, but we have to prepare it. We have to clean it up with a tissue, and then we have to label it. We have to label the original label from the company, or when there's already one time reprocessed, we have the labels from the company who reprocess. Why didn't we do it in our own hospital? We have here surgery materials, and so they are also re-sterilized in our hospital, in a special department for this. But that is more specific, because reprocessing here means to check if everything in this electricity, in the plug, in this not only mechanical but also in the small part in the plug is okay. So the reprocessing is a little more crucial. That is not possible in our hospital, but we are in Germany. We are allowed to do this. What is the challenge? You have to inform and train the staff for this, but because when there are such kinkings in the catheter when we send it back, it can damage the catheter and you can't use it anymore. You have to properly prepare it. You have you needed more space for storage new and reprocessed material. You have a delay in reprocessing that is 2 to 3 weeks. That depends. And in the times of the COVID pandemic, it was much longer because the delivering was not so easy. And we have the great problem that we can't reprocess some catheters because the industry supply only single-use catheters. They are chipped, no? These are special manufacturers. So the chip Here inside this this grip, they're used only for 24 hours available for processing. Our opinion in our hospital is that is not suitable for catheters with lumen, or irrigated catheters, because we have a special conscious about infectious diseases, because the catheters are very long inside the patient. That differs from 1 to 8 to maybe 10 hours. When you have a really long time procedure. Our society is inside the European Society of Cardiology. Part of it is the European Heart Rhythm Association, and David Dunker from Hanover, he did a survey of 2 years ago. How many cardiologists do use this, and that is not that much as we expected, because mostly because of the local or the country regularities, and there are controversial discussion and also a historical development, because there are some papers about destroyed tips. You have also the deflectable curves of these catheters can be damaged by reprocessing. So if you have a reprocessed catheter, it is not that steerable and deflectable as you want to have it, and you have to move your catheters very, very precisely. But we have, I'm so too long? Oh, I'm sorry. Okay, I'm not, so you can see this later in the presentation. These slides, if you have if you need some more information about this special topic. So hopefully there is only one paper about the carbon footprint in electrophysiology, but it's a very good paper. I recommend, and that's so. I hope Future Perspectives is a special this conference to take more awareness about the topic. Thank you.
Sorry. Thank you so much for the presentation, and so sorry to have to cut you off. It doesn't feel nice, never, but also to give the chance to get some questions maybe from the audience. I have one maybe, but I will give the floor to you.
So this is
wait, let me just bring can I bring the mic?
Hello, my name is Annette. Thank you for your presentation. So sustainability is new in your field, or is not new, but sorry, it's not as widely discovered yet.
Yes.
And if you could dream about the future for research in this area, what would you love to look at looking ahead?
I think prevention, in cardiology, prevention is the key. Because once the patient, you have the patient, and you want to help the patient, you need a lot of material. And as we heard about the material you need, so my issue, I work in a sterilized room. Yes, I work in a, we have so much garbage, and we can't reduce this even with reprocessing. With our catheters, we have lowering in our greenhouse gases, and in our footprint. But we have a lot of garbage which can't be avoided, I think, in the next years. And I think the key is prevention. But there is no glory in prevention. And this is reprocessing the catheters is a small part that we can be as an interventional physician I can do, yeah, or using more not only using single-use devices, yeah, to have the focus on.
Thank you. And sorry, oh gosh, what am I doing? Hear this? Well, I see that there is also a question there. Yes, yes, go ahead. Wait, let me bring.
Thank you. In regards to redesigning the cables, because you know all of the different aspects and what's necessary, how could they be redesigned in regards to you have the cables and then you have all the special things you need on the tips for various procedures? So how can you see what would work for a redesign option?
A redesign?
Yeah, how could the manufacturers make that so you can reprocess it?
Yes, I'm not an engineer, but I think there are a lot of options, and when the companies are with us, we talk about this, but and we try to talk to them, to our suppliers, and to make a little, not pressure, not to inform them that we are interested in this. Yes, but we are no green hospital, not yet. But I think in a network, we can have more influence on our suppliers. I think so. Yes, yes, and maybe now I've the possibility to buy to buy a new system, and I will choose not the cheapest one, but the best one. Also in this aspect, yes.
And maybe if I can add a little bit about this, and I think you also mentioned it at one point, that sometimes these products are designed in such a way that they cannot be reprocessed. Like maybe there are some chips that are added so that they can only be used once and then they stop working. So, you know, we talk a lot about programmed obsolescence in our like phones or laptops, you know, when they just stop working at one point. But this is also an issue in this, in the healthcare sector, because these items could potentially be reprocessed and reused, but they are not, because they are designed to last only once. And I've read of other methods. There is some research that looked into it. They also maybe sometimes put some holes into it, or like some really unnecessary parts to like make it harder to clean. So this is very problematic, I think. Are there maybe like one more question? Yes?
Do you know if it's allowed in Sweden to reprocess this kind of equipment?
In my notebook, I have a presentation with a map from Europe where it is allowed it or where not. I don't know about Sweden, but in the coffee break I can have a look.
Yep.
And
There's another thing regarding the medical equipment. When we purchase equipment, we always set up criteria regarding energy consumption and how to dispose them. How is this, are they kind of repairable if something goes wrong, if something is broken? So I think you can do something before you start your examination.
Thank you. Yes, so okay, as I said, like this is not allowed everywhere in Europe, unfortunately, but I think there is still place to change that and kind of advocate for it if you can in your networks. Because I think there is a lot of potential on reducing waste and also reducing costs, because usually the items that are reprocessed are very expensive for the healthcare sector, because it's quite complex items. We don't talk about, I don't know, a gun. It's really more complex items, so there could be a lot of also financial savings if more reprocessing was done. But I think for now we are good. So thank you so much, Andrea, for coming and talking to us about your experience.